So hi guys, so for today we're going to talk about evaluating Laplace transform by table, and this is actually evaluating Laplace transform using the table. So from the previous videos that I have made, it's actually we derived this some of this formula, okay, that we have now for our Laplace table. And as you can see here, we have seven f of t with their equivalent Laplace transform table or equivalent. And this is not the table, the complete table of the Laplace transform. As we can see here, we only have seven, but technically it's really many, okay, transform for some f of t for f of s. So for today, we shall be discussing the basics, okay, of some of the Laplace transform by table. Okay, basics only, such as the Laplace transform, for example, of a constant. It is actually 1 over s. Okay, it's actually any constant we will be having here. For example, 6. The Laplace transform would actually be 6 over s. Any constant here, the Laplace transform is simply that constant divided by s. Okay, and we have seen it on our previous video that I have made, wherein we derive the Laplace transform of any constant, and that turned out to be whatever the value of that constant simply divided by s. And for example, for the second one, we have e raised to at, where a is any constant. The Laplace transform is simply 1 over s minus a, okay, where a is again is any constant, and we also derived this on our previous video. So for number 3, we have the find the Laplace transform of t raised to n, where n is a positive integer, okay, number. And we have the Laplace transform of that would be the n factorial divided by s raised to n plus 1. We would simply divide that by s raised to whatever the value of n here added by 1. For sine 80, where a is again any constant, we have the Laplace transform. I've also shown that on our previous video. We have a over s squared plus a squared. Whatever the value of a here would be squared on the denominator. In terms of cosine, okay, instead that the numerator is the value of a, for cosine it's s. So for cosine we have an s term in the numerator and also in the denominator. Whereas in sine, we have both in numerator and denominator the values of a here. So we have for cosine 80, that is s over s squared plus whatever the value of a here squared. So for hyperbolic cosine or hyperbolic sine of 80, this has similarity with the ordinary sine 80. The only difference is that instead for cosine and for sine, we have s squared plus a squared in the denominator. In the case of the hyperbolic sine and the hyperbolic cosine, did that addition become subtraction? Okay, the same if we have a hyperbolic sine, we have to take the numerator, the a as our numerator, the value, whatever value of a here, over s squared minus a squared. Okay, and for hyperbolic cosine, we have s over s squared minus a squared. So we have to familiarize ourselves with these tables in order for us to solve some transform by table. I guess your professor won't allow you to use this, okay, if he or she is trying to actually let you memorize this, but it depends. So, but it's actually advisable to actually memorize this because during the board exam, it's not even given. Okay? So, some of details. So, let us try to solve some of the Laplace transform. For example, I have an f of t. Okay? I have an f of t. Find the Laplace transform of 5. Okay? So in order for me to find the Laplace transform of this, okay, I know that one property of Laplace is that we can factor out any constant outside the Laplace transform. So this would become Laplace of 1. And we know that the Laplace of 1 is simply 1 over s as per our table. So if we evaluate this should be 5 over s. That's very simple. So whenever we are evaluating a Laplace transform of any constant, we simply divide it by s. Okay? So let's move on now to our second problem. Find the Laplace transform of 2t squared. Okay? 2t squared. So again, it's advisable to factor out the constant outside of the Laplace transform, and we have t squared here. You can only do that if the operation, of course, is multiplication. Okay? So we have 2, the Laplace transform of t squared. And from the table above, we know that the Laplace transform of any t raised to n is actually n factorial over Sn plus 1, where n is the value of the exponent. In this case, our n is 2. So what will happen here, the 2 would be multiplied to the Laplace transform of t squared. So where n is 2, so we have 2 factorial following this formula over s raised to 2, which is our n, again plus 1. So upon evaluating 2 factorial is still 2 because 1 times 2 is 2, and multiplied by 2, so we have 4 over s cubed. So this should be our Laplace transform for the given f of t of 2t squared. So let's proceed now with number 3. By the way, I have at least 10 examples here. So for number 3, we have to find the Laplace transform. Oops, I'm sorry. The Laplace transform of 3 cosine, okay, 2t. Okay, again, we can factor out, again, the 3 outside of the Laplace transform so that we can go back to our table wherein we have the Laplace transform of cosine, okay, for the cosine. So, how would we evaluate this? According to our table, let's go back. If you are not familiar, cosine 80 is s over cosine 80 is evaluated as s over s squared plus a squared. And from our formula a while ago, we know that this 2 here is our value for a. Okay? So we directly substitute it from our table. So we have 3. The Laplace transform of cosine 2t would be s, okay, over s squared plus a squared, which is 2 squared. So if we evaluate that, we have 3s over s squared plus 4. And this should be our Laplace transform for the given f of t, 3 cosine 2t. Okay, another example. Let's try for number 4. For number 4, let's try the Laplace transform. Oops. The Laplace transform of 5t cubed plus 3 sine 4t. Okay. So one property of Laplace transform also is that we can, if we have an addition or subtraction of 2f of t's, let's say, we can actually distribute the Laplace transform. We have Laplace of 5t cubed. We can evaluate them independently. Plus the Laplace transform of 3 sine 4t. That is still equal. Again, applying some properties again, we have the constant 5. We can factor it out outside of the Laplace transform operation. Okay. Plus, we can also factor out 3 Laplace transform of sine 40 so that we can evaluate it using our table. And this, we have seen it already, t raised to n. And again, t raised to n, Okay, let me just rewrite. T raised to n is n factorial s raised to n plus 1. That's the Laplace transform of any f of t raised to n, where n is 1, 2, 3, and so on and so forth. Okay, but for sine at, we have discussed a while ago in our table that that is a over s squared plus a squared. Okay, so let's try to evaluate. We have 5. The Laplace transform of t cubed, where our n is 3. So we have 3 factorial here over s raised to 3 plus 1. Okay? Plus 3, the Laplace transform of sine 40, wherein we have our value of a here is 4. So we have to copy that on our numerator as per our formula. Over s squared plus 4 squared, because that's a squared. So upon evaluating, we have 5. 3 factorial is 1 times 2 is 2. 2 times 3 is 6 over s raised to 3 plus 1, that is 4. Plus, we have 3 over 4. 4 multiplied by 4, s squared plus 4 squared is 16. So if we simplify this, we have to multiply 5 times 6, that is 30 over s raised to 4, plus 3 times 4 is 12 over s squared plus 16. So this should be our final answer for getting the Laplace transform of this f of t 5t cubed plus t sine 40. It's pretty easy if you have the table. Okay, if you also familiarize yourself with the table, it would be really easy for you to solve this problem by table. Let's go now to number 5. I hope you're learning something new today in our video. Number 5, we have to find the Laplace transform of t squared plus 40 minus 5. Okay? So again, applying the Laplace transform property, we have Laplace of t squared minus or plus the Laplace transform of 40. Then we have minus the Laplace transform of 5. So as we can see here, we can solve this by table where our n is 2. And that would be 2 factorial over n factorial here over s squared plus 1. Okay, s raised to 2 plus 1. Plus, this should be for the Laplace transform of t. Okay, then we have minus 5 Laplace transform of simply a 1. So we have 2 factorial. Let's not try to evaluate that first. Okay, and then the Laplace transform of t is actually what? We have plus 4. Okay, it is raised to 1. So our value of n is 1. So we have 1 factorial over s 1 plus 1, n plus 1. Minus 5, the Laplace transform of 1 is 1 over s. So if we evaluate this, this should be 2 factorial is 2 over s raised to 2 plus 1 is s cubed. Plus we have 1 factorial is 1. So multiplied by 4, that is 4 over s squared minus 5 over s. So this should be our Laplace transform for this given problem. So for number 6, let's try again another problem. So we have the Laplace transform of 3e raised to 4t, okay, minus 5e raised to negative 3t. Okay? And if we are going to recall, any Laplace transform of e raised to at would be 1 over s minus a. So that is simply our Laplace transform for some f of t which has an exponential function. So we have to apply again the properties of Laplace transform. We have 3e raised to 4t minus the Laplace transform of 5e raised to negative 3t. We can factor out the constant. Okay, we have e raised to 4t minus 5 Laplace transform of e raised to negative 3t. So we have to get the Laplace transform of this, and this could be solved by table. So that is, in this case, our a is 4. The value of a is 4. So we have 1 over s minus 4 minus 5. The Laplace transform, our a here is negative 3. So we have 1 over, take note of the negative sign. This is minus a. So this is also a negative. So that's the value of our a. So we have s minus the negative 3 because that's the value of our a in the given exponential function. So we have 3 over s minus 4 minus 5 over s plus 3. And this is our answer for this problem. Let's go now to another problem for number, let's say number 7. So this is a pretty easy examples so that you could actually learn from the very basic of evaluating such Laplace transform. So this is by formula, so we can evaluate this individually as cosine, Laplace transform cosine 5t minus the Laplace transform of sine 60. So again, our cosine 80 is actually s over s squared plus a squared. And we have, for sine 80, we have a over s squared plus a squared. So we have s squared plus a squared. So we can evaluate this simply by table. So we have cosine, we have s over s squared plus the value of our a here in this case is 5. So that is 5 squared. Minus, we have sine of 60, that is our value of a is 6 over s squared plus 6 squared. So evaluating that, we have s over s squared plus 25 minus 6 over s squared plus 36. 6 squared is 36 and 5 squared is 25. So this should be our final answer for this problem. It's pretty basic because it actually evaluating Laplace transform by table is actually direct substitution. Unlike the traditional method wherein we are using the integral, that is a long method, so it would be very tedious to solve if we are going to use the definition of the Laplace transform rather than by the table. Okay, for number 8, okay, we have three remaining examples. So 8, we have the Laplace transform of the hyperbolic sine of 7t. Okay, and we know that if we have a hyperbolic sine 80, that the Laplace transform of that according to our table is a over s squared. Okay, the only difference if that is a hyperbolic is that this should be negative. So what will happen is that we have a, which is 7 over s squared minus 7 squared. So we have 7 over s squared plus 49, and that is, that is minus, that should be minus, okay. S squared minus 49. So that would be our answer for this problem. And another one, basic problem number 9. You have to find the Laplace transform of hyperbolic cosine 90. So again, for our problem, that should be cosine or hyperbolic cosine 80 is equal to s over s squared minus a squared. So if we evaluate this, that would be s over s squared minus 9 squared, and that is definitely s over s squared minus 81. Okay, pretty easy. So for our last example for today's video, let us evaluate the Laplace transform of the hyperbolic sine 60 plus sine of 60. Okay, so again, we can evaluate this individually. So for hyperbolic sine 60, we have this equation or this table. So our a is 6. over s squared minus a 6 squared plus this is sine. So simply we have 6, that is our A, over s squared instead of minus, that is plus because that is only a trigonometric function. So we have 6 over s squared minus 36 plus 6 over s squared plus 36. And this is the final answer for our last problem for today's video. And I hope you guys you learned something from today. This is the Laplace transform evaluation by table part 1. See you again on part 2 as what can you expect from the part 2 problems are actually increasing in difficulty. Okay? So, thank you so much for listening. This is again Engineer Abat. God bless you all.